All right, so I'm going to start recording. It is 9 o'clock. Good morning, everybody. It looks like we have 12 people out of 33, so not doing so hot with attendance, even though we're starting school an hour later. I hope you guys are doing well. We're going to go over this warm up as a reminder of what we worked on last class. I hope you guys had a wonderful 3-day weekend. We're going to go over this, and so if you guys have questions, make sure to either use chat to ask questions or to turn on your mic and ask questions there. And you can always email me if you have questions, okay? So good morning. Hope you guys are doing well. Let's unfreeze this and let's take a look at this. So again, what we're looking at here is translations, right? And maybe I need to put that at the top, right? Translation, because that's a new word, right? So again, this is a warm-up with translations. Okay, so today, as you can see with the little banner down below, what we're going to be working on is reflections. So this is a review of translations, and we're going to be doing some new stuff with reflections. Hopefully you guys were successful with your homework for translations. If you guys need help, remember to email me or join my office hours, which are all in the morning, and I can help you out there. Okay, so we will be talking about a new type of transformation today, reflections. Okay, so we're going to take a look at this warm-up. So remember, in English, this is saying every point, right? So this is every point xy such that, and I'm putting commas, my English teacher would probably be very upset with me right there. So every point, that's this first part, such that, that's this part. And then if we take a look at this, this is going to be left 2, and it's going to be up 1. Okay. Now, again, I'm going to go in order because order is really important. Now, some of you might say, well, can't I just combine these and do them at once for an equivalent? And yes, you can do that now for this one. But pretty soon when we get different types of translations, you can't do that. Okay. So we're going to go ahead and take a look at what this is going to look like. So again, we're going to take these points up here. Remember, each of these points has an x and a y. And we're going to take these x's and y's and we're going to plug them into our formula here. Now remember, whenever we do a move, we add a prime. So my new point here is going to be a prime. Right? And what are we going to do with my x? So for my x, I'm going to subtract 2. Well, luckily for us, 0 minus 2, that's one that Mr. Krebs can do in his head. Okay, and then we keep going here. I'm going to take my y here. I'm going to plug it in. So I have 3. How did I get this? This is the problem. So this is what the problem was. It was to take the shape triangle ABC, and then I'm doing these two transformations. So I just made them up. It was just a transformation. I mean, yeah. I hope that makes sense, right? Okay, so then I'm going to go 3 plus 1, so that's 4. And then I have b prime. So I'm going to have 2 minus 2, that's 0. 4 plus 1, that's 5. And then I'm going to have c prime. How am I doing for space? Running out of space. 1 minus 2 is negative 1, and then 0 plus 1 is 1. Okay, so I'll scoot over just a little bit there. So again, all I'm doing is I'm taking my original points and I'm plugging it into the transformation. Now, I'm writing these down because it's important, because I'm going to use these for my second one, right? So I'm going to be using all of these are going to be what I'm plugging in to this one, right? So again, all of my original, that's what I'm plugging into this one. So each time you're using the one before them. Okay. All right, so for this next one, right, it's going to be a double prime. So I have a double prime. I'm going to take my a prime and I'm going to plug it in here, right? So remember, this is my x, this is my y, this is my x, this is my y, this is my x, this is my y. Hopefully the color coordination can work, right? So to get a double prime, I use these x's and y's. So I'm going to take negative 2 plus 1, that's negative 1. I'm going to take y minus, so my 4 minus 3, that's going to be positive 1. Then I have b double prime. I'm going to take 0 plus 1, so that's 1. I'm going to take 5 minus 3, so that's 2. And then I have c double prime. So for c double prime, I'm going to have negative 1 plus 1, that's 0. I'm going to have 1 minus 3, that's negative 2. Okay, and then this is my final answer. Okay, so how are you guys doing with that? We doing okay? Again, we don't have graph paper, so we're not doing this on graph paper, which is kind of frustrating, right? We have to do it all algebraically. But we're just taking the points, we're plugging it in. If we have more than one transformation, right, we take the last one and plug it in, right? It's always the last one. We don't go back to the beginning like we did with conditional statements, right, with if-then statements. Okay. So hopefully, if you guys have questions, you'll ask. Everything in black was given, right? That's just the problem. So when I have x minus 2, right, if you take a look at a graph, right? So in a graph, x positive is to the right, x negative is to the left, y positive is up, and y negative is down, right? So if it says x minus 2, that means I'm going to the left 2. If it says y plus 1, that means I'm going up in the y direction, right? So if you take a look at this, this would be right 1, and this would be down 3, right? So, I mean, so all I'm doing when I'm writing left 1, up 1 is I'm taking a math language and I'm converting it to English, right? So in blue here, that's English of what this is saying in math. It's saying take your x minus 2. Well, that means that if I was up here, I'd be going left 1, 2, because the negative direction is x. So does that answer your question? Does that help out? Yeah, I'm glad that you asked, right? Because that would have been awful if we continued on and you didn't have that question answered. So thank you for asking that question. All right, so translations, again, so we don't have graph papers, so it's always just going to be this in this formula state, right? You're going to have every point such that, and then this is going to tell you what direction you're moving, right? X moves in the left and right, and y moves up and down. If it's positive, it's moving up. If it's negative, it's moving down. In the x direction, if it's positive, it's going to the right. If it's negative, it's going to the left. Okay. And I know it's a little bit harder without the visual cues, and so we're going to, please ask questions if it gets confusing, guys. I want to make sure everyone gets this, okay? All right. So moving on today. So a lot of you guys missed the intro. Remember, all these videos are on YouTube. So we're going to be doing 4.2. We're going to be doing reflections. So reflections is something that we see a lot in our life. There's a lot of ways that we can see reflections. But we don't necessarily know the physics definition of a reflection, right? So we're going to go ahead today and talk a little bit about that, and then we're going to work on how the heck are we going to do reflections without graph paper. And the key is that we're just going to approximate graph paper, and you're going to find that it's really not that hard to do, and everyone can do it, okay? So it is going to take a little bit of plotting points, though, so we might have to review that a little bit. Okay, so how does reflection work? So reflections work. You're going to have a pre-image, a mirror, oops, my R's look bad, a mirror, and an image. Okay, now to do this, I'm just going to show you a quick example. You guys don't need to write this part down. I'm just going to explain the property of mirrors to you. You know, I had this sticky note, and now I don't have a sticky note. That makes me very upset. Oh, here we go. Okay, so what I'm going to do is I don't have graph paper, so you guys don't have to write this down. Okay, and what I'm going to do here is I'm going to make a coordinate system, and this is what we're going to have to do without graph paper. So just don't write anything down. You're just paying attention right now. Okay, So what I'm going to do is I'm going to have a couple of key features here. I'm going to have my original shape. So let's say I have A, B, C. So again, you guys aren't copying this down. Now, what I'm going to do is I'm going to reflect it. I'm glad that you're here. I'm glad that you're here. So what I'm going to do is I'm going to reflect it. So what I'm going to do in this red pen is I'm going to make a dashed line. And this dashed line, this is my mirror. Okay. And what we want to get, right? So this is my pre-image. I want to get my image. So to do this, I brought along, I stole from my wife a little mirror. Usually I have a little bit different mirror at home, but if you guys have, I think this is just like this is Lorac. I don't know, I don't know brand names, but it's just a makeup mirror. And if you have a little mirror in your house, you can do this as well. So what I'm gonna do you see how I have this mirror up and down here? What I'm gonna do is I'm gonna put this mirror down on this mirror line, and we're gonna see what happens. Okay. Now it's not. I usually have better mirrors at school, and we can all do this together. So we're just gonna see what happens. Okay. So I put it down like this on here, and then I'm gonna have to tilt a little bit because the edge is a little thick. But what you should see is, and I'm gonna go like this and just rotate it back and forth, is that now I have an image, right? In the mirror, I have this image. Now notice, and you can see this with my finger, right? Notice as I get closer to the mirror, my image gets closer to the mirror. And if I touch the mirror, I'm touching my image, right? So we have this relationship with distance to the mirror, right? So notice how B is really close to the mirror. So in my image, B is really close to the ear. A and C are equidistant to the mirror. So they're equidistant, right? So the idea is as my pre-image gets closer to the mirror, my image gets closer. And as my pre-image gets further away, my image gets further away. And I just wanted to demonstrate that. I know it's not as exciting as it is in person to do that. Okay. So we're going to have three pieces, right? You're going to have your pre-image, a mirror, and an image, right? So for the mirror, use a dashed line. Use a dashed line for the mirror. Okay, so when I say dashed line, I mean like this. And the reason that we're going to do that is that so you don't confuse it with the X and Y axis. Okay. And then the key here, and I'm going to put this in the stars, the distance from the pre-image. Okay, and I'm going to slow down so you guys can get this all down. So the distance from the pre-image, so the distance from the pre-image to the mirror is the same, and I'm going to underline the same because that's the most important. So the distance from the pre-image to the mirror is the same as the distance from the mirror to the image. Okay, so the distance from the pre-image to the mirror is the same as the distance from the mirror to the image. Okay, now that's a lot of writing, right? And it's like, oh, come on, Craft. But let me give you a picture definition of this. Now, again, we don't have graph paper. So what I'm going to ask is we're just going to do the best we can, okay? So the graph, all it is an aid, right? So with that in mind, we don't need graph paper to have an aid for us, okay? So to do this, I'm just going to make up a triangle, okay? So let's do an example of this and see what's going to happen. So let's do an example of this. So I'm going to make up a triangle. So let's say given we're going to say triangle ABC, where let's say A is, let's say -3, 2. Let's say B is -1, 1. And let's say C is -4, 1. Okay. So we're given this triangle. We have triangle ABC, and we have 1, 2, 3 points. Okay. And then we're going to reflect triangle ABC over the y-axis. Okay. Now, some people forget, but the y-axis is actually the line x equals 0. Okay, so that's just a little review there, right? So x equals 0 is the y-axis, and you hopefully learned that in Algebra 1, right? So, which is weird. I know a lot of people get confused. It's like, well, why is it x equals 0? It's the y-axis. Because remember, x equals 0 means all the y's change and x doesn't change, right? So the y-axis is changing in y, but not changing in x. So x stays the same. All right, so what we're going to do is, to do this, we're just going to make a quick little graph like this. So I'm going to make, so if you want to be really fancy and impress your friends, this is called a Cartesian plane, but we can just call it a coordinate system. So what I'm going to do is I'm just going to make a 4x4 grid. Okay, because I see we have -4 is my biggest. So I'm going to go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So, and as you can see, I'm not super exact, right? And you don't have to either. You don't need to use a ruler or anything. We're just using this as a way to have a visual aid, okay? Because with reflections, there are formulas sometimes, but there's not formulas all the time. So we have to be able to do this because you're going to have some issues with graphing, okay? All right. So the first thing I'm going to do, once I have my little 4x4, is I'm going to plot these on here. Now, remember, guys, y is up and down, x is left to right, okay? Now, some people who struggle with graphing, I tell them to do this. Before you start graphing, go like this, and then just above the x, put left to right, and the y is up and down, okay? If you need a little bit more, you can always just go like this and be like, this is x positive, y negative, x negative, y positive. Okay, so if you're struggling with getting points down, which is the most common mistake that is made when graphing points, right? This is it right here. Then I would just write this down every time you have it, or have it on a little sticky note, put it next to your computer. Okay, or have it in your notes that you can easily remember, right? X is left to right, y is up and down. When you have a positive y, it's up. When you have a negative y, it's down. When you have a positive x, that's to the right. When you have a negative x, it's left. So if I were to be graphing the point -3, 2, then I'm going to go left 1, 2, 3, up 1, 2. And that's going to be point A. And I might even go like this. I might even say -3, 2. Okay? So that way I'm like, even if I drew terribly, I knew what that is. And then obviously this isn't a very good one. Mine's going to be really small. I should have done better planning here. -1, 1. So this is going to be B, and B is at -1, 1. I'm going to regret that. Oh well. I'm already regretting writing that there. And then I'm going to have C is at -4, 1. So C is at -4, 1. And then I can connect them like this, and I get a little triangle. Okay, now we're all drawing this by hand, so ours are going to look a little bit differently. All we need to know is where they're located, right? So this is just a visual aid. We're not trying to be a Picasso. This isn't supposed to be beautiful. It's just a quick and dirty. The quicker the better, right? So it doesn't have to look good. It just has to be functional. Okay. So the next thing I'm going to do is I'm going to draw in my mirror. So my mirror, I'm going to use a dashed line. So it's the y-axis, or x equals 0. So I'm going to go like this. And I'm going to do this because in the second here, we're going to be moving our mirror. But it's important to remember that, right, this isn't just the y-axis. This is also x equals 0. This is my mirror. Okay, that's my mirror going up and down. Okay. So to reflect this, what we're going to do is we're going to find the distance from each point to the mirror. Okay. So let's go ahead and take a look at how this works. So let's start with point A. Our distance that we're going to find is always perpendicular. And I don't have time to get into that. We don't have a lot of time today. But the shortest distance between 2 points is perpendicular on a flat plane, not on a curved plane like our planet. But that's a different type of geometry. So what we're going to do is we're going to find the distance between this point and the mirror. And that's what this was saying. The distance from the pre-image to the mirror is the same. So we just have to find that distance. So if I'm at A, how far away am I from this mirror? I am 1, 2, 3 away. Okay, so you guys can see, and we're always finding our perpendicular distance. You don't have to draw on the 90-degree angle, but it's always perpendicular because that's the shortest distance between 2 points. So I'm going to go 1, 2, 3. Now get this. That distance is the same as the distance from the mirror to the image. So on the other side, I'm going to count 1, 2, 3. I'm not going to move up or down. And then this is my A prime. So my A prime would be at, what am I at now? Positive 3, 2. And see, the reason why we have this visual is to get the coordinates. I can go 1, 2, 3, and then up 1, 2. Yeah. No, so, right. So basically, like, there's a pattern here, right? And that's all good and fun as long as we're reflecting over the y-axis, right? So in a second here, I'm going to start moving things. And then that's where we're going to have to do this method. So don't just be like, I found a shortcut. Yes, I started with one that was really easy, and there is a shortcut for this one. And I'll tell you that in a little bit. But we're starting with this one because it's easy to do. So we're going to do this with all points. So B here, remember how I said I regret writing it there. B here is 1. So on the other side, I'm going to go 1. So then I have B prime. So, and you have to label. So B prime here is right 1, up 1. Okay. And then C prime is 1, 2, 3, 4. So I'm going to go 1, 2, 3, 4. So here's C prime, and that's at 4, 1. So I'm going to have. Now, I use 2 different colors. If you're just using a pencil, what you can do is you can make this a dashed line, right? So if you do a dashed line here, then that way you know which one's your image, but also labeling it as C prime. So my answers here, right? A prime is at 3, 2. B prime is at 1, 1. And C prime is at 4, 1. And that's my answer. Okay, so again, the key here is finding the distance to the mirror because that's going to be the same as the distance away from the mirror. Yeah. So again, shortcuts are good and are all good and stuff, but we're gonna do one now where there isn't a shortcut, right? So there isn't a shortcut. So this was the basics for this. Okay. Does anybody else have questions about this? There's some good questions in chat. Yeah, so we're going to do more complicated ones here in just a little bit. Okay. I agree with you guys. Some of you guys have seen this before, and that's great. All right. Right? Because reflections and translations, right, are basic. So now we're going to get a little bit more complicated. So I just want to do a quick review. How are we doing for time? I think we're doing okay. So we're going to do a quick review on graphing vertical right? So when I say vertical, that's up and down, and horizontal lines. Oops, I'm off the page there. So graphing vertical and horizontal lines. Okay, so vertical means up and down, horizontal means left and right. Okay, so I'm going to do a quick review on this. And here's the quick review. Vertical lines is x equals, right, a number. And horizontal is y equals a number. Okay, that's it. Now we're gonna do a couple of different things in this. So why is this vertical, right? So it's vertical because x stays the same. And y changes. Okay, and then here, y stays the same. And x changes. Okay, so remember, how does x change? X changes left to right. How does y change? Up and down. So what you're doing here is you're saying x and y are fixed and they're not moving. So in a horizontal, you have a fixed height, and here you have a fixed left or right, right? So elevators have a fixed position in the building, and then they go up and down, right? Okay, and then if you were to walk around the floor of a building, like a multi-stored building, right? Then you would be moving left to right, but you'd be staying on the same floor, right? Because floors are up and down. Okay. So let's just do a couple of examples of this. Okay. Now, if I was, oh well, I don't care. Okay. Let's do one that is a little bit more difficult. So let's say, so here's example number 2. So we're going to have, I'm going to give you 3 points. So we're going to have triangle A is 1, 3. And I'm going to have triangle B is 5, 2. And triangle C is 2, 1. Okay. So what we're going to do is we're going to reflect triangle ABC over x equals 3. Ooh, let's do 2. And then 2, we're going to reflect it. Triangle ABC over y equals, what are we going to do? Y equals 1. Okay, and we're going to treat this as 2 separate problems, not one problem. So we're not going to do a composition with this. Okay, so we're going to do 2 different ones. So the first one here, I'm going to make a coordinate system. Okay, now I look here, and it looks like I have 5. So I'm going to make a 6 by 6. So I'm going to have 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. And again, I'm just eyeing this, guys. Like, this is not graph paper. If you have graph paper, go ahead and use it. That's cool that you have that. But you don't need it, okay? So I'm not saying you need to go out and buy graph paper, okay? All right, so what we're going to do is we're going to graph our original shape. We're going to graph our mirror, okay? So the first thing I'm going to do is graph this original shape. So remember, in case you guys forgot, right? We have x, y. The x goes left to right. The y goes up and down, okay? And so I can even label these like that. Okay, so my first one is A. I'm right 1 up 3. Okay, so here's A. B is at 5, 2. So 1, 2, 3, 4, 5, up 2. So here's B, and then C is at 2, 1. Okay, so I'm going to have like that. Okay, again, all of our shapes are going to look a little bit different, but that's okay, right? Because it's just a visual aid. Okay, so I have my A, my B at my C. Okay, and again, we're just doing this off of this. I'm going to slow down just a little bit because I know sometimes this takes a little bit longer. Okay, so now what I'm going to do is I'm going to draw in my mirror. Okay, so my mirror, I'm going to use this blue. Okay, so this is going to be my mirror. So x equals 3. So I'm going to go right 1, 2, 3, and I'm going to just put 1 point there. Now, remember, if you forget how to graph x equals 3, y equals 1, remember to graph a line, you only need 2 points. So we just got 1 point. So we have to find one other point that has an x of 3. Well, if I go right, that's an x of 4. And if I go left, that's an x of 2. So I can't go left or right. But what I can do is I can go up. So if I go here, I know this is 3, 6. And so I'm going to have a line that looks like this. This is the line x equals 3. Because if you look at every single point up and down, every single point is going to have an x of 3. The x stays the same. Okay? You can think of this as the elevator is 3 doors to the right when you walk in. You go up the elevator, you're still 3 doors to the right in the entire building going up and down. Okay? You can tell my graph isn't very good because these lines don't look parallel, right? All right, so what did I get? I got my pre-image, I got my mirror, and now what I'm going to do is I'm going to find the distance. Now, this one, as you guys are probably noticing, it's really different. There is no formula here, okay? There is no like, oh, I just changed the x, okay? So to do this, I'm going to have to count distances, but notice something else that's weird because we don't normally have this. I have some pieces of my shape on the left side of the mirror and some pieces on the right side of the mirror. And in our notes, it said nothing about side. And so that's what's important. It doesn't matter what side of the mirror you're on. To reflect, you find the distance to the mirror, and that's the same as the distance away from the mirror. So, for example, if I start with B, okay, and I find my distance here, it is 1, 2. So B prime then is going to be on the other side, 1, 2. And so right here is my B prime. Okay, do you guys see how it was 2 on either side? Now, this 2 looks a little bit longer. That's just because my graph isn't super great. Okay, but that's all we need it for. We need to be able to count. So my B was on the right. It's reflected. Now it's on the left. Okay, let's try the A. So the A is 2 away. So now it's going to go 2 over. And so this is my A prime. Oops, I maybe went too far with that here. I'm at an angle. There we go. I'm just going to put an X there. So my A prime is right there. Okay. And then C is 1 away. So I'm going to go 1 away over here, and this is my C prime. Now, again, I have different colors. If you guys don't have different colors, you can go ahead and use dashed lines for your new shape. So yeah, and the answer is yes, it gets messy. It gets messy. So there's my new shape. So what I'm going to do next is I'm just going to write down my coordinates. So what do I have? A prime. What's my A prime? So my A prime's here. It's at 1, 2, 3, 4, 5. So I'm 5 to the right. And how many up am I? 1, 2, 3. Right? So that's not going to help you on the state test, so I don't recommend doing that. Because on the state test, you're not going to have any tech. Yeah. Right? Or you bust out your pocket mirror, right? And you go like this. There is, actually. Yep, and you can't have, yep, there's lots of rules because there's lots of ways to do this that are tricks. So here we go, we got B prime. So B prime, it looks like it's right 1 up 2.
and then C prime, it looks like it's right 1, 2, 3, 4, up 1. Okay, so there's
that first reflection. Okay, so let's recap what we did here. We just drew a really rough coordinate system. I plotted my original points, A, B, and C. Then I drew in my mirror, and then I find the distance from the pre-image to the mirror, and then I do the exact same thing on the other side. And it doesn't matter what side.
now.
Totally. Doesn't this get really ugly when it's all on top of each other? You're absolutely right. But it's messy,
And with practice, you'll get really good at it. Okay.
so this was an example of a reflection over a vertical line.
So now we're going to do the exact same thing, but with a
Horizontal line. So again, this takes a little bit longer with no graph paper. So I'm just going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, and so this is just a 6 by 6. And again, don't spend a lot of time on doing this, guys. This is just an aid. So I'm going to graph the same points again. I'm not doing a composite here. I'm just graphing the same points. So I'm going to have 1, 3. So that's my A. And then I have 1, 2, 3, 4, 5, 2.
Oh my gosh, I have to look over this. So that's my B. And then I have my C at 2, 1. So I'm going to go ahead. And of course, my triangle looks a little bit different, right?
Because my, do you guys see how my triangle looks a little bit different? Because my coordinate system's not square. So that's why it's important, right? Graphing paper is really nice. So again, I'm going to slow down just for a second because I know that sometimes doing this can take some time. But remember, the goal here isn't to be super precise. It's just supposed to be a rough sketch so you can count and you can visually see, because there is no formula for what we're about to do. I mean, there is, but it's like the amount of time it would take to get it isn't worth the time. It's easier just to sketch it. So
here, I'm reflecting over y equals 1.
okay, so this means up 1. It's all the points.
Up 1, right? You can think of this as all points up 1.
Okay, so if I go here, here's 1 point up 1. And if I go over here, here's another point up 1. So it is all my points up 1, right? This is y equals 1. Okay, and notice, right, that it's all the points up 1, right? All the points up 1. Okay. So this one doesn't go through the shape, right?
But there is one interesting point in that C.
But do you guys remember what happened when I have a point that's on the mirror, right? Here's my finger touches my finger, right? So if you know, maybe some of you didn't, ooh, that's kind of a weird image. Do you guys like having multiple angles of my face? If you guys didn't have a Valentine's date, you can always kiss a mirror and you're kissing someone because you're kissing yourself, because your lips will be touching your image's lips.
Okay, so
what we have here, what we're going to do is we're going to start. So remember, I'm always going to count perpendicular. So because this is a horizontal line, I'm going to count perpendicular down. So A here is 2 away from the mirror. So on the other side, I'm going to go 1, 2. So then that means right here is A prime. Okay, so notice how I went 2 down, and then I go 2 down again. C, what's really cool about C is on the mirror, right? So that's also the location of C prime. It's the same thing here. I can try to make it red. There we go. Right? So that's really easy, because what's the distance to the mirror? The distance is 0. And if it's 0, then it's 0. So B is 1 away. So on the other side, I'm going to go 1. So then this is B prime. So then you can connect them. Again, if you don't have a color, you can just do a dashed line. And so let's write out the coordinates. My A prime is going to be to the right 1, down 1. B prime looks like it's to the right 1, 2, 3, 4, 5. and it's down or up nothing. And then C prime, it's going to be to the right 2, up 1. Okay. So again, when what you're reflecting over isn't the x and y axes, you there is no formula. And you can derive a formula. It's just not worth your time. It's just easier just to go quickly like this because you have to redefine your formula every single time, and it's just really not worth it. Okay. And you're not going to remember it. That's really the big thing. It's like I could teach you guys how to write a formula for this, but when you have to take a state test next year, you're not going to remember that formula. Like there's just no way you're going to remember it. Okay. Which is funny because I'm going to teach you a formula next. Now, the reason why I'm teaching you a formula next isn't because I think the formula is good to teach you. I've never taught this formula before. The reason why I'm doing this is because we don't have access to graph paper. So we literally have to use the formula. Now, I hate formulas because if you don't remember the formula, you can't do anything. Okay? So this is a one-time I'm teaching this. I've never taught this formula before because it's a waste of time. Because in real life, unless you're doing this all the time, you're not going to remember this. Okay, so this is for your notes. Okay, so coordinate rules. For reflection. Now, I'm going to warn you, these only work for 4 situations. So what we just did here, right? So going back, what we just did there, you're going to have to be able to do that by hand. Okay, so let's go over the 4 situations. 1, if AB is reflected over the y-axis. Okay, so if AB is reflected over the y-axis, we did this one, right? And someone pointed out, oh, you just changed the y, and that's what happens. So you would get A negative B. Okay, so that's one formula. Now remember, this only works for the y-axis. If you move it off the y-axis, you can't use this. Okay. And I just want you guys to know I am adamantly against using these formulas. I think it's a waste of time. Now you're like, well, then why are you teaching this? Again, we don't have access to graph paper. Okay? So I think teaching you these first 2 is a waste of time, but I'm going to teach you the last 2 anyway, so we might as well do all of them. So AB is reflected over the x-axis, then you're going to end up with negative AB. Okay, and I didn't explicitly say this, but A and B are just numbers, right? So some number A, some number B. Okay, and we'll use the last few minutes to practice using these. Now, again, I really do think that that memorizing these are a waste of time. Okay, but the next 2, I have to do these next 2 as formulas because we're not going to be able to do this without graph paper. So for the next 2, let's just call this. So for diagonals, okay, because this is the big one. So these are the ones that you really need to have in your notes. These 2, you could still just graph these and do that just fine. But for these, you can't do these with a fake graph. You have to do, the only way you can do this is with real graph paper. We don't have real graph paper, so you guys need to know these. Okay? And that is if you have a point AB and it is reflected over y equals x. Now, some of you are like, wait, how do you graph y equals x? If you have forgotten what y equals x looks like, That's y equals x. Okay, now I wish I had more time, but I only have 4 minutes left. This is insane. I wish I had more time, guys, because I would talk to you about why y equals x is so important. Y equals x is so important because as you go on, this is how we find inverse functions. This is the geometric way of finding inverse functions. And if that means nothing to you, oh my gosh, this is so cool. And I wish I had more time to make this relevant to you and more fun. I don't though, so let's just do this. So the equation is if you start with AB and you reflect it over y equals x, you get BA. And if you think about that, it makes sense because it's literally y equals x. So what was x? A. So y literally equals x. And you can read it backwards too. X was A. Well, x literally equals B now. Right? You guys see how it just switches the x and the y. So this one is actually really easy to memorize. This one is so important. As you guys move forward in your math career, this is going to be a very big idea. Okay? And I wish I had more time because I'm running out of time now. The other one is if AB is reflected over y equals negative x. And this one will also make sense. It's the same thing, but they change sign. Okay, so you switch the y and the x, but they also change sign. So these guys are really important. You can't do these with a fake, you can't do those with a fake graph. Okay, because you're not going to be able to count the diagonals, which we can't do if our diagonals aren't square. Okay, so I don't have a lot of time left, and I just feel really sad because this stuff is so cool, but you guys are just going to learn, just get a little intro. So let's say I have, I have to do some really quick examples. So let's say I have, a segment AB where A is at -1, 3, and B is at 2, -2. Okay, so I want you guys to use these formulas. We're just going to practice using the formulas. So 1, we're going to reflect segment AB over y equals x. And then 2, I want you to reflect segment AB over y equals -x. And then 3, you're going to reflect segment AB over the x-axis. Okay, so in our last couple of minutes together, just practice using the formulas. Okay, so remember when I say AB, you're just taking, this is your AB, what happens to it, right? So just to be super clear, you guys are going to find A prime, B prime. You're going to find A prime, B prime. You're going to find A prime, B prime. Using the formulas that we just wrote down. So because of coaching, all my office hours in the morning, they're 6:35 to 8:50 in the morning. Every day but Wednesday. Wednesday's email only because I'm in meetings all day. Okay, now, hey guys, I'm really sorry again. Like 50 minutes isn't a lot of time, so I'm just going to really quickly go over this. So remember the formula for this is if you have a point AB, y over x is just going to be BA. So we're just going to take our x and our y's and we're going to switch them, right? So A is now going to be my y, B is now going to be my x. So this would be 3, -1, and -2, 2. Okay, so I'm just switching my x's and my y's. And then here, my formula is AB, and then I'm going to have -B, -A. Now, with this, you guys see how I'm showing my work? Writing the formula down is showing work. Okay? So I'm going to switch A and B, but the negative means I'm going to change the sign. Change the sign. So I'm going to switch them, but now, do you see how this is positive, this is negative? Now this is negative, and that's positive. Now this is positive, and that's negative. Okay, so I switch them and change the sign. It's kind of like the contrapositive, isn't it? Where you switch them and change the sign, and this is kind of like the converse. It's almost like we learned that for a reason, but I just don't have time to talk about that. And then over the x-axis, I take point AB, and I get negative AB. So then x prime or A prime is going to be 1, 3, and B prime is going to be -2, -2. Again, right? You just change the sign of the x. All right. Unfortunately, guys, that's all we have for today. So I'm trying to give you guys a really basic intro. I hope you guys are doing okay. Make sure you're getting your homework done. Please ask questions, guys. You're not in this alone. You can do this. I'm here to help you. I don't want you to feel like you're alone doing this. I know this is a lot and a little bit of time, okay? So please come to my office hours if you want. We'll do the homework together. If you have questions, email me, or you can stick around after class and ask questions.